Within the manufacture of medical examination gloves, the FDA allows for a certain amount of pinholes, which I consider inadequate and detrimental to physicians and medical personnel. My proposal will reduce and quite possibly eliminate these pinholes. This thin-walled mold made of a special alloy has wear resistance and releasing properties, resulting in a glove mold free of any defects. The mold tensile strength averages between 60 to 80,000 psi, approaching the metal hardness of mild steel, achieving a perfect, dense surface free of any cast inclusions resulting from sand or porosity inherent with thick sand-cast aluminum molds. It is durable to the point of being considered a permanent mold, allowing the surface to be reconditioned as necessary if nicked or worn. The primary advantage of this mold is heat conductivity, allowing extremely fast curing and cooling cycles, drastically reducing energy cost associated with slower heating cooling cycles inherent to aluminum or ceramic molds, eliminating the need for mass amounts of production molds and vastly decreasing the total capital outlay for mold production. Other important features are its thickness and uniformity, allowing for shorter dip tanks, drain distances, and cooling sections. The overall superior cure in fingertips and webs reduces instance of pinholes to near zero. The mold accepts vinyl, latex, rubber, as well as urethane, used in the production of needle-proof gloves, essential for medical personnel, firefighters, and law enforcement.